ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ವಿದ್ಯಾರ್ಥಿ ಪ್ರತಿಭಾ ಶೋಧ ಯೋಜನೆಯ 75ನೇ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಶ್ರೀ ಚೈತ್ರ ಅವರನ್ನು ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ವೆಲ್ಕಮ್ ಟು ಯು ಮ್ಯಾಮ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಹಾಗೂ ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿರುವ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಸಹೋದ್ಯೋಗಿಗಳು, ಅಧ್ಯಾಪಕರು ಹಾಗೂ ಶಿಕ್ಷಕ ವೃಂದದವರನ್ನು ಕೂಡ ಈ ಒಂದು ವಿದ್ಯಾರ್ಥಿ ಪ್ರತಿಭಾ ಶೋಧ ಯೋಜನೆ ವೇದಿಕೆಗೆ ನಾನು ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ವೆಲ್ಕಮ್ ಟು ಆಲ್ ಆಫ್ ಯು. ಈಗಾಗಲೇ ಚೈತ್ರರವರು ಹಲವಾರು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ನಮ್ಮ PU ವಿದ್ಯಾರ್ಥಿಗಳ, ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಹಲವು ಬಾರಿ ಉಪನ್ಯಾಸ ನೀಡಿದ್ದು, ಅವರ ಬಗ್ಗೆ ನಾನು ಆಗಲೇ ಕಿರು ಪರಿಚಯಗಳನ್ನು ಮಾಡಿಕೊಟ್ಟಿದ್ದರಿಂದ ಮತ್ತೆ ಕಾಲಾವಕಾಶವು ಕಡಿಮೆ ಇರುವ ಕಾರಣ ಅವರನ್ನು ನೇರವಾಗಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಮತ್ತೊಮ್ಮೆ ಸ್ವಾಗತಿಸುತ್ತಾ ಅವರಿಗೆ ವೇದಿಕೆಯನ್ನ ಬಿಟ್ಕೊಡ್ತಾ ಇದ್ದೇನೆ. ಓವರ್ ಟು ಯು ಮ್ಯಾಮ್.
Yes sir, thank you so much. Hello students, good evening. In the last class we completed preparation of amines. So in today's class I'm going to continue with the chemical properties. Fine. I hope you have revised all those preparation methods. We studied approximately 6 preparation methods of amines. Majorly we spoke about the preparation of primary amines, right? So among that there were 2 named reactions. One was Hoffman's ammonolysis and the other one was Hoffman's bromamide degradation. And the last one, there was one more named reaction, that is Gabriel phthalimide reaction. Through that also you synthesized amines, right? Let's start with today's session, guys. This is the most important part of amines chapter, that is chemical properties. Before starting chemical properties, I just want you to revise few physical properties of amines, right? As soon as I tell physical properties, you might remember about the physical state. Physical state, in which state they are present, okay? Either they are solids, liquids or gases. So beginning, we start with the lower amines. You consider methylamine, ethylamine, all those. These lower amines are gases and they possess a characteristic smell or odor. You would have heard, right? Whenever you check amines odor in laboratory, preferably it will be fishy odor, right? That is because of the presence of trimethylamine, right guys? And higher amines, generally they will be in liquid state, that too they'll be volatile in nature, okay? They'll be volatile liquids. Whereas if you consider, these are for aliphatic amines. Aliphatic amines are open chain structures, whereas if you consider the aromatic amines, lower amines will be liquids, whereas higher amines, they will be preferably solids, okay? Can you give me one example for aromatic amines? Last class we dealt with so many aliphatic amines, yes or no? Can you give me one example of aromatic, guys, students? Aromatic means what? Now, in a simple manner, you have to have benzene ring, right? Can you tell me one name of the amine which is aromatic in nature? Yes? You can type the answers and send, guys. Yes. It will be aniline. If NH2 is directly attached to benzene ring, it is called as aniline. This is one of the important aromatic amine which we will be regularly using. And one more thing in physical properties you have to remember is intermolecular attractions or interaction. Guys, if you are listening, can you tell me what is the intermolecular force between amine molecules? For example, if you take CH3NH2, I know between carbon and nitrogen what kind of bonding is there? covalent bond, right? Can you tell me between two methylamine molecules, there is attractive force, right? What kind of attractive force is present? Can you repeat it? Yes, students, you can give the answers. So between two amine molecules, there will be a intermolecular force of attraction, which is not so strong like hydrogen bonding and all, like strong hydrogen bonding. But you can observe here, I will pictorially show this, RNH2. This is the general amine, right? On nitrogen, there will be lone pair of electrons. Now, one more amine I'll write in this manner, NH2R. NH2R. If you have studied the definition of hydrogen bonding, yes. What is the definition of hydrogen bonding? Can you revise? Here, nitrogen is covalently bonded with this hydrogen. This covalently bonded hydrogen shows a attractive force with the next neighboring amine. Hydrogen is attracting this nitrogen. This is the electronegative atom. If you can remember, we have told between hydrogen and the most electronegative element, fluorine, oxygen and nitrogen, if the interaction is there, we call such interaction as hydrogen bonding. Correct, guys? So this is called as hydrogen bonding, but this is a weak intermolecular force of attraction. I'm not telling hydrogen bonding is a weak intermolecular force of attraction. This is strong only, but between hydrogen and nitrogen, whatever the hydrogen bonding is present, now that strength of the attraction will be little bit lesser when compared to fluorine and hydrogen, when compared to oxygen and hydrogen. So as the electronegativity decreases among FON, fluorine, oxygen and nitrogen, who has lesser electronegativity? Nitrogen, right? So nitrogen shows the weak hydrogen bonding. So I can tell this is weak hydrogen bonding in case of amine. Okay. So just keep in mind the interaction. And next, one more point in physical properties, we will come across solubility, right? Whether the amines are soluble in water or not. Obviously, we know that generally amines are more soluble in organic solvents, or if you consider any organic compound for that matter, they are more soluble in organic solvents. But if you consider the lower amines, they are also soluble in water. Because of what, guys? Because of what amines are soluble in water? Can you give me the reason? What kind of intermolecular force we told just now? It is hydrogen bonding, right? Therefore, because of the presence of hydrogen bonding, solubility of amines can be explained with respect to water. So lower amines are soluble in water because of hydrogen bonding, right? But you know what is the relationship between solubility and molecular mass, how they are related? How solubility and molecular mass are related? They are related inversely. So greater the molecular mass, lesser will be the solubility. So this is the general trend. You have to remember lower amines are soluble in water because of the tendency to form hydrogen bonding, whereas as the molecular mass increases, the hydrophobic part increases, therefore solubility decreases. Okay. Anyhow, aromatic amines are insoluble in water because of the largest hydrophobic part, right? So one more physical property is boiling point. This is very important physical property, right? Again, how boiling point is related to molar mass? What is the relationship between boiling point and molar mass? Yes, boiling point is directly related to molar mass. Greater the molecular mass, greater will be the attractive forces, or greater is the intermolecular force of attractions. Therefore, greater is the greater is the boiling point. So boiling point and molar mass are directly related. Now, for example, if I take CH3NH2, this is methenamine. Then I'll take CH3CH2NH2. Among this, who has got greater boiling point? Can you tell me? See, here only one methyl group is there. Here bigger group is there, ethyl group. So for whom molecular mass will be greater? For the second one, ethylamine, right? Therefore, ethylamine has greater boiling point than methylamine. How did you check this? Depending upon the molecular mass. Now, one more case I will give. Now, I will take isomeric amines. Isomers means all of you know they are the species with same molecular formula, right? But different physical and chemical properties. Now, I will take propanamide. Can you see the number of carbon atoms here? This is 3 carbon atoms. So it is propanamide. Next, I'll take the isomer of this. I'll write CH3CH. Sorry, 1 minute. Okay, I'll write here once again. I'll take CH3, CH2, CH2, NH2. This is propanamine. Next one, CH3, CH2, NH, CH3. Here the molecular formula is same only, but I have written different isomer. Now one more, I will consider NCH3, CH3, CH3, lone pair will be there. Everywhere on nitrogen, lone pair of electrons will be there. Now you check the number of carbon atoms and hydrogen atoms, guys, here. C3. What is the molecular formula of everything, whatever I have written? It is C3. H, how many hydrogen atoms are there? 3, 4, 5, 6, 7, 8, 9. So H9 is there. And how many nitrogen atoms are there? 1 nitrogen atom. So all of them have same molecular formula. Now I have to compare boiling point of these isomeric amines. Means I have to take in consideration of what, guys? The surface area, right? Now you can also tell here the order is primary amines will have greater interaction. Primary amines are having greater boiling point than secondary, than tertiary. Actually, this can be told with respect to surface area as well as with respect to hydrogen bonding tendency. Okay. In today's discussion, I'm going to show you why primary amines have greater boiling point. It is because of the greater stabilization during hydrogen bond formation. Now, if you ask me the values, this will have 323 Kelvin as the boiling point.
ಚೈತ್ರ ಮೇಡಮ್ ಹಲೋ,
Yes, sir. Yes, sir.
ಆ ಮಧ್ಯೆ ಅವ್ರಿಗೆ ಅಲ್ಲಲ್ಲೇ ನಿಮ್ಗೆ ಒಂದು 5 to 10 minutes ಒಳಗಡೆ ಒಂದು ಸಣ್ಣ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ.
Yes, sir. Yes, sir. Yes, sir. ಕೇಳ್ತಾ ಇದೆ. Yes, sir.
Okay.
Yes. Yes, sir. Thank you. So this will have 307 Kelvin as the boiling point. This will have 276 Kelvin as the boiling point. Now, later on in this today's class only, we will check how many hydrogen bondings are possible. For now, I will tell you here 3 hydrogen bondings are possible, here 2 and here 1. So how I will show you with respect to these molecules dissolved in the water. Okay. So you remember the general order. What is the general order for boiling point for isomeric amines? It is primary greater than secondary greater than tertiary. Okay, guys. So how boiling point is related to molecular mass? Directly. Okay. Yes. Let us start with the chemical properties. So chemical properties of amines. So students, can you tell me which is the most important chemical property of amine? Most important chemical property of amine, yes. Yes, you can tell. One point you tell, or any one reaction, whatever you remember, you can quote it. The amino compound which you remember, or the basic ammonia you can tell. Yes, guys, you can respond. See, I'm writing NH3. This is a base, right? Why ammonia is basic in nature? Can you tell me? We call ammonia is a base, right? Think on nitrogen, what will be present? Yes. On nitrogen, what is present here? There is one lone pair present on the nitrogen, right? That's what makes ammonia basic. Similarly, if you have amines, let me write the general formula, RNH2. You check the valency of nitrogen here. What is the valency? Here one single bond is there. With hydrogen, two bonds are there. So nitrogen has got three valencies here, right? But in the valence shell, how many electrons will be there in nitrogen? Remember nitrogen atomic number 7, right? Can you tell me the electronic configuration for nitrogen? It is 1s2, 2s2, 2p3, right? Now, if you write S subshell and P subshell, how many electrons are there here? In S orbital, how many electrons are there? 2. And P, how many electrons are there here? 1, 2, 3. So total 5 electrons are there. But here, how many valencies are there for nitrogen? Only 3, right? So 2 electrons are present as unpaired electrons or unshared electrons on nitrogen. Correct, guys? Are you understanding? Now, the most important chemical property of amines is the basic nature. Okay, so let's start with first chemical property, that is basic nature of amine. Okay, so before starting with amines, let me take with the comparison of ammonia itself. So already I wrote ammonia here. You know on nitrogen what is present here? Lone pair of electrons. So I can call ammonia as base. It can be called as a Lewis base. Can you tell me the definition of Lewis base? You have studied 3 acid-base theories, right, guys? One is Arrhenius acid-base theory. Second one is Bronsted-Lowry acid-base theory. And the third one is Lewis acid-base theory. So can you tell me, according to that, ammonia is Lewis base. What is the definition of Lewis base? Yes, Lewis base. Lewis acid and Lewis base. Classification of substances into acids and bases. So Lewis acid is one which is by itself electron deficient. So it requires 2 electrons to complete the octet, whereas Lewis base is electron rich species which is electron pair donor, right? So on ammonia there is 2 lone pair of electrons. 2 electrons are there, 1 lone pair of electron is there. So this is called as Lewis base. Also it is called as Bronsted base. It's also called as Bronsted-Lowry base because according to Bronsted-Lowry concept, acid is one which is proton donor, whereas base is one which is proton acceptor. Right, guys? So now see here, ammonia, both the cases I will show you. Ammonia is there. It will accept H plus because here see lone pair of electron is there. This act as a nucleophile or electron rich species. Can you tell me H plus act as what? How many electrons H plus has, guys? It doesn't have electrons, right? Actually, hydrogen atom has one single electron. Now I have removed that also. So H plus means it is electron deficient species, right? It has tendency to accept a pair of electron. Now you will get NH4, ammonium ion, right? That's why ammonia is a base. Ammonia acts as base because it works as proton acceptor. So according to Bronsted-Lowry concept, ammonia is a base. According to Lewis acid base concept, again what? Ammonia is also base. Because according to Lewis base definition, electron rich species or electron donor, a pair of electron donor is called as Lewis base. Okay. So I can write for this particular reaction period, instead of this, I can also write ammonia reacts with water. How water ionizes H plus and OH minus. This H plus can take over this lone pair of electrons and you get ammonium ion because this is Lewis base. Now plus OH minus is there. Now I can write the base dissociation constant for this Kb, ammonium ion concentration into OH minus ion concentration divided by ammonia concentration. Okay. So this is approximately taken as 1.8 into 10 power minus 5. I hope in equilibrium chapter you would have learned how to calculate all these values, right? If I give Kb value, you can also tell me what is the pKb value. Kb and basic strength are directly related. Kb and basic strength are directly related. If I give Kb values and ask you to tell who is more basic, greater the Kb value, greater will be the basic strength. Okay. So similarly, if I compare the same thing with amines, amines also basic in nature because RNH2. If I take this as the general formula, guys, can you tell me again on nitrogen what is present here? Lone pair of electrons, right? Can it accept proton? Yes or no? Nitrogen contains lone pair of electron. You can see clearly here. Yes, because of the presence of lone pair of electron, nitrogen can accept a proton. So amines are also basic in nature, like ammonia only. Okay, you got alkyl ammonia ion. Fine. So what is the reason amines show basic nature? It is all because of the presence of lone pair of electrons. Fine. So greater the Kb value, greater will be the basic strength. Greater will be the basic strength, whereas greater the, or we will tell in this way, lesser the pKb value, smaller the pKb value, greater is the basic strength again. So pKb and Kb, they are related, or pKb and basic strength, they are related inversely. Okay. Now in today's class, let me elaborate this basic properties of amines and tell who is more basic among amines only. Okay guys. So there are so many types. In this first case or first type I am considering is alkyl amines. Alkyl amines means you have R group, which is alkyl group, versus ammonia. Okay, let me consider the basic nature of this. Now all of you know ammonia is what? NH3. That's it. On nitrogen there is lone pair of electron. So to take one alkyl amine, I will take this example, CH3NH2. You can also take any alkyl group. You can take ethylamine, propylamine, butylamine, etc. But whatever the R group you have attached, that is alkyl group. Now, guys, can you tell me, compare the basic, see, here also nitrogen contains lone pair of electrons. Here also nitrogen contains lone pair of electron. Can you tell me among this methylamine or methanamine and ammonia, who is more basic? Quickly. Both are basic in nature because of the presence of nitrogen with lone pair of electron. But among this, who is a stronger base? You have to tell me. Yes, think and tell me. Yes, very good. Yes, Pooja, very good. So, what is the reason? Can you tell me why methylamine is greater than or stronger than this normal ammonia? Now, since nitrogen carries lone pair of electron here also and here also, both are basic in nature. But why is this methylamine stronger base than ammonia? Yes, very good, Sanjana. It is methyl group is electron donating group or electron releasing group. This act as electron releasing group. So what does electron releasing group does? It pushes the electrons in the nitrogen. Already nitrogen had lone pair of electron. So since electron releasing group is attached, it even more pushes the electrons. So the electron density on nitrogen atom, now what happens, guys? It increases. Therefore, basic nature of methanamine or methylamine is greater than ammonia. Do you agree with me? Okay, very good. Okay, this is the first case. Now, I will write a order. Among that, you have to tell me which is a stronger base and which is a weaker base. Okay. Now, I'll write ammonia. This is the general formulas I'm telling. You can tell me what is the nature of the amines. This is one amine. And next, I'm writing this one. And one more, this. Everywhere on nitrogen, lone pair of electrons are there because the valency of nitrogen here is 3. Correct? Guys, can you tell me among this? This is just normal amine, ammonia. This is primary amine because nitrogen is directly attached to how many carbon atoms, guys? Can you look this and tell me? It is attached to how many carbon atoms? One single carbon atom directly, right? So this is, yes, very good, Pooja. So this is primary amine. Can you tell me this is what kind of amine? Nitrogen is directly attached to how many carbon atoms here? Yes, very good. Secondary amine. Here nitrogen is directly attached to how many carbon atoms? So this is a tertiary amine. Yes, great. Okay. Now you have to tell me among these 4 structures, whatever I have written, which is a stronger base. I agree, all are basic in nature because nitrogen carries lone pair. Yes, very good, Sanjana. It is tertiary amine. Yes, guys, you can reason it out here. Here, nitrogen contains just one lone pair. Here, nitrogen is directly attached to R group. Can you tell me? R group means you can imagine methyl group also. Now, this is acting as an electron releasing group, right? It pushes electrons on this nitrogen. So, the electron density on the nitrogen increases. Whereas, in the secondary case, 2 alkyl groups are attached. Whereas, in the tertiary case, 3 alkyl groups are attached. Therefore, in which case the density, electron density on the nitrogen atom increases, guys? In the tertiary case. So, who is the weakest base among this? Ammonia. Then primary amine. Then secondary amine. So, can I generalize this order? Tertiary amines are more basic than secondary, than primary, than ammonia. Yes or no, guys? Correct, right? So can you identify this is due to which electron displacement effect? You have studied inductive effect, electromeric effect, resonance and hyperconjugation, right? This electron pushing effect or electron donating effect of alkyl group is because of what? It is because of inductive effect, right? Plus I effect. This is the plus I effect. Based on that, we have given this order. And one more thing you have to remember is this is in gaseous phase. When the amines are in gaseous phase, this order is accepted. So please, you have to note it down. This is in gaseous phase. Tertiary is greater than, secondary is greater than primary. Okay. Now, whereas if you consider the aqueous phase, you have completely different basic nature. So ultimately, if they ask question with respect to gaseous phase, what is the basic nature of amines? you will be telling tertiary is greater than, secondary is greater than, primary is greater than ammonia. But in aqueous phase, with respect to steric hindrance, completely the order will be different. So what is that? We will go through in our class. Okay. So due to the plus I effect, you have this order, but in aqueous phase, unexpectedly, different order is observed. So why is that? We are going to consider two factors, and finally we are going to compare everything and conclude what is the basic nature of amines. Okay, guys, next one after this, let me take the steric effect. Because of the steric hindrance, what will happen to the basic nature of amines? Okay, now you tell me, I have primary amine, secondary amine and tertiary amine, and ammonia also. If you want, you can compare. With respect to the steric effect, which amine will be most basic? Now, yes, you can think, if the lone pair of electrons are more available for somebody who is in seeking for that electrons, that particular substance becomes a stronger base. Correct? So if I have three compounds, all are able to give the electron for electrophile, who gives in a better way, who gives that lone pair of electrons in a better way, that becomes a better base. Correct? No? Now let me write. Yes, very good, Sanjana. It is primary amine. Correct. Now let me take one example. Methylamine I am taking, and secondary amine, dimethylamine I will take, and next one, all the nitrogen lone pair is there. Next one again I am taking tertiary amine. Okay. Now you tell me, you told according to plus I effect, this is more, tertiary is more basic. But now what happens here? One group is there, here two groups are there, here three alkyl groups are there. Don't you think, actually for convenience I have written like this, otherwise you will have the shape of, what is the nitrogen hybridization in amines, guys? Think and tell me hybridization of nitrogen. It will be sp3 hybridization, right? But does it have tetrahedral geometry? No, it will have pyramidal geometry. Because of the presence of lone pair, it has distorted tetrahedral structure, guys. Now, in these cases, this is more crowded. Don't you think more alkyl groups means more crowding? Because of this crowding of alkyl group, what is happening? Those alkyl group cover the nitrogen from all the sides, and they make the approach. For example, some proton is there, it seeks electrons, it is electron deficient, it want to take this electrons. Now can you tell me who gives that electrons very easily? According to plus I effect, you can't think now. You have to think based on the steric effect. That's the heading I have written. Now, if you consider here one alkyl group is there, here two alkyl groups, and here three alkyl groups are there. Now tell me, H plus is accessible for that electrons in which case? In the case of which amine? See, here so much crowding will be there because of the bulky alkyl groups. It is not just proton, it is bulky alkyl group. So in which case this H plus can go and accept that lone pair of electrons easily. Don't you think it is primary? Yes. So I can make a general statement, more number of alkyl groups, So what will happen? Greater will be the steric hindrance. Therefore, who is least basic according to this? So tertiary amine will become least basic. Who is most basic, guys? Do you accept this is the order now? According to plus I effect, just now you only told tertiary is most basic, then secondary, primary, ammonia. Now you tell me according to steric hindrance, which becomes most basic? Primary, because this lone pair of electrons are well accessible for a proton in the case of primary, whereas As the number of alkyl groups increases, steric hindrance increases, therefore basic nature decreases. Okay, but do you agree this is the basic nature of actual amines? Yes or no? Tell me quickly. Do you agree this is the correct basic nature? Yes, quickly you have to answer. Do you think this is the basic nature? You have read NCERT, right? Which amine is most basic? Whether you consider any example, methanamine you consider or ethylamine you consider, which amine is most basic? Primary, secondary or tertiary? Yes, Sanjana, you can answer. So according to plus effect, we saw one order. According to steric hindrance, we saw one order. But ultimately, when you check for methylamines, the actual basic nature order is secondary will be greater than, primary will be greater than tertiary. Correct, guys? This is the order, right? For methylamine. So why is this? It is not accepting that first order whatever we wrote, or is the steric hindrance order, it is not accepting that also. So let us try to understand why this unique or unusual basic nature is explained for methylamines. Or you can, for that sake, you can take ethylamines also. But if you take ethylamines, can you tell me what might be the order? Obviously, yes, secondary would be more basic, then comes tertiary, then comes primary. Let's start understanding. Yes, shall we go ahead? Why this is the actual basic order? So if you open NCERT and check, at last note, basic nature of amines are written like this with respect to methylamine and ethylamine. So if you compare, secondary will be most basic. If you consider methylamine, after secondary, primary, then tertiary. In ethylamine, after secondary, tertiary is greater than primary. Yes, are you interested to understand why that is the order? Shall we go ahead? Yes. So the last concept which is related to actual reasoning for the basic nature is hydration effect. Hydration effect. So that is also nothing but solvation effect. Hydration or solvation effect. If you understand this, you will get idea why secondary amines get more basicity. Okay. So hydration effect is nothing but, guys, it is a stabilization of protonated amine. Now basically what you are doing is you are taking the amine, you are dissolving it in water. Are amines soluble in water? You have to answer yes or no. Amines are soluble in water or not? So when you dissolve these amines in water, what is going to happen? So that is explained with respect to hydration effect. So stabilization, this is nothing but stabilization of protonated amine. Okay. By what? By water molecules. When you dissolve in water, what happens to these amine molecules? Okay. So basically, you have that idea, amines are soluble in water, so therefore water molecules form hydrogen bonding with protonated amine, and they release some energy which is called as hydration energy. So greater the energy released, greater is the stabilization, more stable is that particular amine. Got this point? So basically this hydration effect, it depends on the stability of conjugated acid form by accepting a proton from the solution. Okay, so how this will form? If you have doubt, you know that ammonia or amines on nitrogen, what is present? Lone pair of electrons is present, right? That can accept a proton, right? So finally, those protonated amines, they react or they form hydrogen bonding with this water molecules, and they release some energy which is called as hydration energy. So greater the energy release, greater is the stabilization. Are you with me, guys? Yes. So we are coming to the last part. Observe clearly here. So greater the extent of hydrogen bonding, greater the extent of hydrogen bonding in that protonated amine, greater will be the stabilization. So now let me explain it to you. I will take a primary amine. What is primary amine general formula? RNH2. Can you tell me how many protons it will accept? Primary amine. On nitrogen there is a lone pair. How many protons it can accept now? One particular proton, H plus ion, requires how many electrons? 2 electrons, right? So what is formed here? R, it will accept a proton, RNH3. Now can you tell me on nitrogen what is the charge developed? This H plus takes that lone pair of electrons and forms a bond. So what charge should be developed on the nitrogen now? Yes. There has to be positive charge, right? Can you tell me what is this? This is protonated primary amine. Why it is called as primary amine? Because nitrogen is directly attached to how many carbon atoms? One carbon atom, right? Now I will open and write the structure. Now RNH3 plus is there. RNH. Now what charge is present on the nitrogen, guys? It is positive charge. Now this is called as primary protonated amine. Now can you tell me how many hydrogen bonding it can form? Yes, guys, quickly speak. How many hydrogen bonding it can form with water molecules? Here, one proton is there, hydrogen is there. With oxygen, it can show the hydrogen bonding. Yes, you have to answer. Observe, no, how many hydrogen atoms are there? Okay, can you tell me the number of hydrogen bonding here? See, this is H2O. Don't get confused. So there are 3 hydrogen atoms here. So how many hydrogen bondings are possible? 3 hydrogen bondings. So this is in primary protonated amine. So next one, let me take secondary protonated amine. So secondary amine means R, N, H, R. On nitrogen there is lone pair of electron, right? Now you add H plus for this and tell me what will be formed. R, N, H, 2R on nitrogen positive charge. Now open and write that structure. I have R, N is there, and for that 2 hydrogen atoms are attached, and here one more R is there. What is the charge developed on nitrogen now? Positive charge. Can you tell me, at least you have to speak, yes, how many hydrogen bondings are possible? Now you compare with the primary amine and tell me, in the case of primary amine, how many hydrogen bonding you saw? 3. 1, 2, 3. And can you tell me here how many hydrogen bondings? Yes. Okay. So it is 2 hydrogen bondings. Now, last one, I'll take tertiary amine. Tertiary amine, here also you have 3 R groups and 1 lone pair of electron. Now you add H plus for this and tell me what is the ammonium ion form? R, N, R, R. This H plus will accept that electron and you will have H. On nitrogen, what is the charge developed now? Positive charge. Can you tell me at least now how many hydrogen bondings are possible? How many protons are available here? Only one, right? So what is the hydrogen bonding? How many hydrogen bonding? Only one. So in this case, 3 hydrogen bonding, in this case, 2 hydrogen bonding, and this case, only 1 hydrogen bonding. So can you tell me, I told here only, you observe here, what did I tell? Greater the extent of hydrogen bonding, greater the stabilization, therefore more stable will be that particular amine. Now can you tell me, among primary, secondary and tertiary protonated amines, who has greater number of hydrogen bonding, that should become more stable. So among these three, who is more stable? Yes, primary amine, protonated amine. Ananya, don't mistake. See, greater the number of hydrogen bondings, greater is the stabilization. Now, among primary and secondary and tertiary protonated amines, where the number of hydrogen bondings are more? Yes, check Ananya. Here only, no? Here 3 hydrogen bondings are there. So, it's not tertiary, it is primary. So, this is least stable because number of hydrogen bonding is lesser. Now, so in actual, okay, now according to that, tell me what is the basic nature of amines? Yes, Sanjana, Ananya, you can answer. According to these, according to plus I effect, I told you, observe here, according to plus I effect, what is the basic nature? Tertiary greater than secondary greater than primary. According to steric effect, primary greater than secondary greater than tertiary. Whereas according to solvation effect, which is most basic, it is greater the stabilization, greater the hydrogen bonding, greater is the stabilization. So don't you think in this case, in terms of solvation effect, yes, what is the order? Basic strength order, primary will be greater than, secondary will be greater than tertiary. Correct, no? Now, in actual practice, you will not see plus I effect order. You will not see steric hindrance order. You will not see solvation effect order. It is a combined effect of all the parameters, whatever you have taken into consideration. So in actual practice, now if you consider plus I effect, you exactly gave the ulta order, right? Now you have, when compared to solvation effect, exactly opposite here, right? Now in actual practice, these two opposing factors, one is plus I effect, another one is the solvation effect, two opposing factors, they balance each other in case of secondary amines. They balance each other in case of secondary, amines. Now you tell me, when you took plus I effect, what is the order you told? Tertiary greater than, secondary greater than, primary? No. This is for plus I effect. Yes, solvation effect, exactly opposite order you are telling. But who is in the middle? Always primary and tertiary are the extremities. Who is at intermediate stage always? Correct, no? Secondary, are you observing this? Now, since these two opposing factors are there, they will balance out in the case of secondary amines. That makes secondary amine is more basic than primary. Okay, since this is not experiencing the extremities, it is the intermediate of tertiary and primary in both the cases. Secondary will be more basic in practical cases. Okay, but when you consider methyl and ethyl group, the order changes. So we can conclude that it's a combination of electron releasing effect and the hydrogen bonding and steric effects determines the stability of the amines. Now I'll tell you two cases. You remember exactly like that. Now, for example, if I have methylamines, what is the order means? You can write if you want. And second one is ethylamines. Again, the orders change. At last conclusion, you have to remember these things only. Now, in case of methylamine, yes, secondary will be most basic. In case of ethylamine, again, secondary will be most basic because these opposing forces or opposing factors, whatever we took, they balance out each other in those secondary amines. Whether you take methylamine or ethylamine, you have to remember who is most basic, that is secondary. Now I'll write here CH3 twice NH. This is secondary amine, methylamine. Secondary ethylamine means what is the formula? C2H5 twice NH. Now, can you tell me in case of methylamine, now I have left out with primary and tertiary. Among that, who is most basic? Can you tell with respect to what I can tell? Or I'll write out the order. You convince me what might be the reason. In case of methylamine, secondary should be first, then comes primary, then comes tertiary. Whereas in case of ethylamine, tertiary comes first, then comes primary. Yes, can anybody explain why is this? I'll write the formulas. By that time, you tell me what is the reason. You have to consider both inductive effect as well as solvation effect and answer this. Try at least. Yes, guys? Do you agree this is the last part of basic nature you have studied? In case of methylamine, it is secondary greater than primary greater than tertiary. In case of ethylamine, it is secondary greater than tertiary greater than primary. So here I told, if you consider both the effects, whatever we studied, it balances out in secondary. That's why whether it is methyl or ethyl, secondary should be most basic. Okay. Now, when you take methyl amines, why primary is greater than tertiary? Observe here. Can you tell me, according to solvation effect, whatever we studied, solvation effect, who is more stable? Where the stabilization is more? In case of primary or tertiary? How many hydrogen bonding was there in primary and tertiary? You imagine. You will get the answer. So in case of primary, right? So here what dominates in methylamine is solvation effect dominates. The stabilization through solvation dominates. Okay, that's why primary is greater than tertiary. Here also secondary is only first. Can you please tell me why tertiary is greater than primary in this case? Observe the structure here. So what is the reason? What might be the reason here? Why did I write tertiary is more basic? Now imagine here, nitrogen is attached to 3 alkyl groups. So, and this is a big bulky group. So don't you think there will be greater stabilization effect by plus I effect? Do you agree, guys? So in case of methylamine, solvation effect through primary amine is greater. That's why primary is greater than tertiary. And in case of ethylamine, plus I effect, because of the bulky ethyl groups, the plus I effect becomes more dominant. That's why you have tertiary greater than primary. Okay. So once again, you quickly revise off through plus I effect, you wrote tertiary greater than secondary greater than primary. Through steric hindrance, you wrote primary greater than secondary greater than tertiary. Through hydration effect, again, you wrote primary greater than secondary greater than tertiary. But ultimately, what exactly you have to remember is this order. This is in aqueous phase. They will mention in aqueous phase what is the order. In one of the NEET paper, they have asked exact order with respect to methylamine. Did you understand? So easy, right? Methylamine means what is the order of basic nature? This is the gist. That's it. Summary. Yes. If you tell this, you have understood. Can you tell me in case of methylamines who is most basic? Secondary. After that who should come? Primary. Then comes tertiary. Why is this order? In among tertiary and primary who is most basic means stabilization through solvation effect you took. In case of ethylamines, who is most basic? Secondary. Among tertiary and primary, who is more basic? It is tertiary. Why? Because of what reason you told? It is because of the bulky group, ethyl groups plus I effect, which is dominant. You had tertiary greater than primary. Okay. This is the gist of basic nature of amines. Guys, did you understand? So after that, one more case I will take. Did you understand this? Shall I go ahead with the next part? Yes. Okay, good. Okay, thank you, Anand. Okay. The next one is I will consider aromatic amines versus alkyl amines. Now, you compare and tell me among aromatic and alkyl amines, who is most basic? Yes. If you want one example, I'll give. General example, I can write like this. Aryl amine, aromatic amine, like this I can write. Alkyl amine, like this I can write. Okay. Here also a nitrogen lone pair is there. Here also a nitrogen lone pair is there. If you want one particular example, let me take aniline, which is the example, most important example for aromatic amine. We have aniline. Okay. This is aniline. Yes, guys, you compare and tell me, then I'll explain it to you. I have C2H5NH2. This is ethyl amine. Who is most basic? You have to tell. That's it. Both are basic in nature. Which is a stronger base or which is a better base? Aniline or ethylamine? Who is a better base? Who gives that lone pair of electrons for somebody who is seeking the electron is a better base? Can you tell me? Eradu kade nitrogen has lone pair. Correct? ಯಾವುದು ಪ್ರೋಟಾನ್ಗೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಪ್ರೋಟಾನ್ ಓನ್ಲಿ, ಯಾವುದು ಆ ಪ್ರೋಟಾನಿಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಈಸಿಯಾಗಿ ಕೊಡುತ್ತೆ ಅದು ಒಳ್ಳೆ ಬೇಸ್, ಬೆಟರ್ ಬೇಸ್. ಎಸ್, ಕ್ಯಾನ್ ಯು ಥಿಂಕ್ ಅಂಡ್ ಟೆಲ್ ಮಿ ಅಮಾಂಗ್ ಅನಿಲಿನ್ ಅಂಡ್ ethylamine? Very good, Ananya. Yes. So among aniline and ethylamine is most basic. This is less basic. Why? Because yes, in ethylamine, nitrogen is directly attached to what kind of group? What is the C2H5? It is an electron releasing group, right? Same logic. It pushes the electrons on nitrogen. Nitrogen has already lone pair. So the electron density on the nitrogen increases. So it can give that electrons for outsider who is in seek of that electrons very easily. Can you tell me what happens here? If I ask you, will that nitrogen is basic in nature? Yes, you will tell because it has lone pair. But why it is not a better base? Can you tell me what is happening? Why it's not acting as a better base? Because of what effect, you tell me? Either it is inductive effect or resonance effect, you tell me. Now, what is resonance also you know? Yes, try to answer. Now, you know that aniline, here NH2 acts as an electron releasing group. It gives the electrons towards the benzene ring. So, what effect it is causing, guys? It is causing plus R effect, right? Plus R effect. Electron releasing nature it is showing. And you have understood in terms of resonance here. In case of benzene, this lone pair, this pi electrons are not stationary. They'll be continuously delocalized. Bond become charge, charge become bond. So, in aniline, what is happening? This bond become charge. Now, in that reason, this carbon has lesser valency, right? This lone pair of electrons comes here. Next resonating structure is this. Now, you have here bond already. Now, this bond become charge. Now, here how many bonds I have to write for carbon? 4 bonds. Nitrogen is there. H2 is there. Nitrogen lost the electrons. Now, positive charge you write. Now, again, this negative charge shouldn't be localized, right? It should be continuously delocalized. This charge become bond, bond become charge. Once again, one more resonating structure you can write. Here it is becoming negative charge. Here you are getting a bond. Now double bond as it is. Here you don't do anything, continue it. Throughout the ring, that negative charge will be delocalized. Again, charge become bond, bond become charge. Now you have benzene ring. Again, negative charge become bond. Now you have one more negative charge here. Now continuously that negative charge will be delocalized, right guys? Now once again, charge become bond. This bond neutralizes the positive charge of the nitrogen. Till where you have to write the resonating structure, till you get the original structure. Now you got NH2. Now what is the reason why aniline is lesser, or it don't want to give the electrons very easily? Why it's a weaker base when compared to alkylamine? Because rather than giving that lone pair of electrons for outsider, that lone pair of electrons will be involved in what effect? They will be involved in resonance effect, right? So that's why aniline is a weaker base when compared to alkylamine. Okay, now I'll write 3 example. You give the order. I have aniline, aromatic amine, ammonia, and ethylamine. Can you tell me among this who is a better base? Who is the strongest base among aniline, ammonia, ethylamine? If you want structure also you write. Yes, yes, you can answer. Try. Who is the better base? Who gives that lone pair of electrons very easily? I told already in the case of aniline, the lone pair of electrons are not easily given because it is undergoing resonance. Whereas ammonia, yes, on nitrogen lone pair of electron is there. But in case of ethylamine, what is happening? There is an electron releasing group which is even more pushing the electrons on the nitrogen, and electron cloud increases on nitrogen. Therefore, it becomes a better base. Yes, among aniline, ammonia and ethylamine, who is a better base? Very good, Pooja. It is ethylamine. So who is a weaker base among these three? Aniline is a weaker base than ammonia, because here it is not undergoing any resonance. This lone pair will be available. Whereas when compared to ammonia, who is most basic? Ethylamine. That is suggested by Kb values. How Kb and basic strength are related? They are related directly. So here Kb value is 4.2 into 10 power minus 10. Here it is 1.8 into 10 power minus 5. So this is 5.1 into 10 power minus 4. So this is a greater value. So this is most basic. Did you understand? One more comparison I'll show you. Next one. I'll take aniline here, guys. What is aniline? Benzene ring directly attached to what? NH2. On nitrogen, there is lone pair of electron. Now, I will add H plus. Will it accept that H plus, yes or no? It has lone pair, means it has to accept, right? But it is not a better base. I'm not asking how strong it is, but will it accept a proton? Yes or no? If it accepts a proton, what do you get? What is this compound name? Can you tell me? If it accepts a proton, you get NH3. On nitrogen, what charge I have to write? Positive charge. This is called as anilinium ion. Like ammonia accepts a proton, means you will call it as ammonium ion. No, this is called as anilinium ion. Now, can you tell me how many resonating structures are there for aniline? Up in this class only up we wrote, no? How many resonating structures are there for aniline? Yes, count, no? How many structures are there total? 5 structures, right? So you wrote 5 structures. So aniline is a resonance hybrid of 5 resonating structure. Whereas anilinium ion has how many resonating structures you write? It is not an electron releasing group. Here positive charge is there. Just you can shift these pi bonds to alternate positions and tell one more resonating structure is there. So total number of resonating structures for anilinium ion is how many? 2 structures, right? Can you tell me then who is more stable? Among aniline and anilinium ion, who is more stable? Aniline is more stable. Okay, so this explain, because of resonance you can explain, greater the number of resonating structure, greater is the stability. So anilinium ion is less stable than the aniline. So in this case there are no lone pair of electrons only. This can act as a better base. So as a summary point, you just understand what is the effect of substituents on that benzene ring. Now if I have a benzene ring, okay, and if I attach an H2, this is aniline. Okay, now what I'll do, I'll attach an electron withdrawing group for this. If I'll show like this, if I attach a electron withdrawing group, what happens for basic nature? And for aniline, again, if I attach electron releasing group, what happens? Electron releasing group. Electron releasing group, some examples you give. Give some examples for electron releasing groups. You have all alkyl groups, right? Alkyl groups releases electrons. You have OH group, you have OR group, all these act as electron releasing group. Electron withdrawing means you have halogen, among that fluorine, chlorine, bromine, iodine is there. You have NO2 group, CHO group, COOH group, all these are electron withdrawing. Now tell me, both the cases on nitrogen lone pair is there, no? If electron withdrawing group are there, means what they do? They pull the electrons towards themselves, right? They pull the electrons towards themselves. Electron releasing group, they give the electrons towards this benzene ring. Now, electron withdrawing group, basically, they decreases the electron density. Electron density on whom? Electron density on nitrogen. Therefore, what happens? Basic nature of amines, what happens here? Basic nature, it is only pulling electrons, means what happens? Electron density on nitrogen decreases. Therefore, basic nature also decreases, or basic strength of amine decreases. Whereas, if electron releasing group is attached to amine, what happens? Nitrogen has lone pair, but these are pushing the electrons on ring and further on the nitrogen atom. Therefore, electron density on nitrogen atom increases. Therefore, what happens to basic nature in this case? Basic nature also increases. So the summary is electron withdrawing group decreases the basic nature, whereas electron releasing group increases the basic nature. Okay, in today's class we have understood clearly what are amines, why they are basic in nature, and what is the order of basic nature in terms of gaseous phase and aqueous phase with respect to solvation and plus effect. And we have also compared alkyl amines versus aryl amines or aromatic amines basicity. You told that alkyl amines are more basic in nature. And lastly, I have clear with respect to effect of substituents on aromatic amines. Okay, this is all about the basic nature of amines. This is the first chemical property of amines, which is very important, because in second year you have studied all acidic nature of alcohols, phenols, carboxylic acids, but amines is the one and only chapter where you have studied basic nature, right? Yes, guys. If you have any questions, you can ask me doubts, or you can send. Any doubts? Are you clear with this topic today, whatever we conducted? Just finally, you have to remember this order, whatever I wrote. This is the most important point. Yes? Any doubt?
Okay, thank you, ma'am.
Yes, sir.
So chat box ಅಲ್ಲಿ ಯಾರು ಮಕ್ಕಳು ಕ್ವಶನ್ಸ್ ಹಾಕಿಲ್ಲ,
Yes.
ಕಳಿಸಿದ್ರೆ ನಾನು ನಿಮಗೆ ಮೇಲ್ ಮುಖಾಂತರ ಕಳಿಸ್ಕೊಡ್ತೀನಿ.
Yes, sir. Yes, sir. ಅದೇ ಅವ್ರು ರೆಸ್ಪಾಂಡ್ ಮಾಡಿ ಕೆಲವೊಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಏನು ಡೌಟ್ ಇಲ್ಲ ಅಂತ ನೋ ಅಂತ ಕಳ್ಸಿದ್ರು.
Yes, ma'am.
Yes.
Okay, anyway, thank you. I would like to thank you immensely for delivering a very informative and insightful talk on Amines. Behalf of KST and myself, thank you, ma'am.
Thank you, sir. Thank you, sir.
ಸೊ ಹಾಗೂ ಇಂದಿನ ತರಗತಿಗೆ ಹಾಜರಾಗಿದ್ದ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಸಹೋದ್ಯೋಗಿಗಳು, ಅಧ್ಯಾಪಕರು ಹಾಗೂ ಶಿಕ್ಷಕರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ, ನಾಳಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಚೇತನ್ ರವರು ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಎಂದಿನಂತೆ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಜರಾಗಿ ಆ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಕೇಳಬೇಕೆಂದು ನಮ್ಮ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ಮತ್ತೊಮ್ಮೆ ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. Thank you once again, ma'am.
Yes, sir. Thank you so much.
Okay, bye.